This talk about indexing came out of a workshop that Peter Judge from Progress and I did last year. We turned it into a talk. And what we found really was that a lot of programmers just didn't have a really good understanding about index selection and indexing in their code. So we wrote this workshop about indexing, and this is kind of the 1-hour presentation view about this topic. So we found a couple of things. One, we found that people didn't know the tools that were available to them so that they could analyze their index usage. And then the other thing they didn't really know is they didn't really understand the subtleties about how the compiler selects indexes, and then how do things like ands and ors and parentheses and stuff confuse the index selection in your head, not in the compiler's head. So I want to go over all of those things with you. All right, and then some subtleties at the end if we have time, just some special cases that we're going to talk about. So I assume everyone's here a programmer? Yes, pretty much? Good. For those that, I looked down and then it got louder. That's why I don't like these mics. For those that don't know me, I've been doing this for 25 years. I'm not a programmer. I'm the guy you call in after your garbage code has been breaking production and everyone's yelling and you don't know how to fix it, and you call me, and then I come in and then I show you all these tools to help you fix all of these things. All right? And again, I've been doing this for 25 years, really on the technical DBA side, not on the programming side at all. Though I have been known to write some code, but it's not a good idea to let me do that very often. And Whitestar's been around for, 30 plus years now. We're not even sure what the official first year is. I think it was 87. So we've been around for a good 30 plus years. So we're the oldest, I think, independent consulting firm in the world. The BravePoint guys used to challenge us for that oldest, and then they got swallowed up by the mothership, and so now we're probably the oldest consulting firm out there, independent consulting firm. And we're the author of ProTop, so you'll hear me talk about ProTop today too. You can come see ProTop over at the booth if you want more details about it. And just a couple of quick slides, because like the gentleman, Mr. Dr. Taylor said, you got to pay the bills a bit. There's a free version of ProTop, real-time monitor. So a lot of the stuff we're looking at you can see in real time with the completely free version. And you can connect to the web portal, so we'll give you free 24 hours of trend data. And with the paid version, you get more advanced monitoring, you get alerting, and you get 3 years of trend data. And we'll give you trend data on stuff really at the table and index level too, amongst a whole bunch of other things that are part of the paid version. But come by the booth if you're interested in hearing more about ProTop. And we are running a contest. We're giving out Starbucks gift cards, but we're also giving out a free 90-day subscription to ProTop if you're interested. So again, come by the booth for that. All right. So this talk kind of started because it was the third iteration of our 4GL performance workshop that I did with Peter Judge. And the second iteration, we did a little section on indexing, and we realized that all the people in the room, because it was a hands-on workshop, they had no idea what I was talking about. They all been who's been programming for 15 years? 10 years? Less? No? So we found that everybody thought they knew the rules about index selection, and more or less 90% of you were wrong to some extent. They just didn't understand. And so when we did this workshop 2 years ago with a little piece of indexing, we realized people just didn't understand. So last year, we blew this out into a full 3-hour workshop and this 1-hour presentation only talking about indexing. And while we were doing our research, if you look in the progress documentation, it says this: the precise rules are numerous and complex, and it's not important for you to fully understand. You know, when someone tells me that, really what they're saying to me is they don't understand the rules to explain them to you, so they're going to say, no, it's too complicated. You don't need to understand any of this. But no, it's very important that you understand exactly how the compiler selects their indexes, because that'll come back into how you do your code. And you'll see we're going to try to twist your thinking to look at index selection a different way. All right? All right, here we go. So first, the first thing I want to remind you of or show you guys is there's just a whole bunch of tools out there that are available to you for extracting this information. And we're going to talk about a few of these. One is ProTop, of course. the free version, you can get real-time visibility into what tables and indexes you're using. My personal favorite is Log Manager. I know I'm a ProTop guy, but Log Manager, I love Log Manager. I'm a total Log Manager junkie when it comes to Log Manager. It's a little too verbose, but I love it anyways. And who's doing dynamic query coding here? And none of you? A few of you? A couple? So with dynamic query, you can look at the query object handle, and you can pull out the information property. It'll tell you which indexes are being used. All right? And for those that don't know me, if you have questions, just shout them out. And you know, even though Scott said it, I tell it everywhere. If your phone rings, I know you're all working. Get up. Don't answer the phone. I've had people answer the phone in my talks. That, I think you're crossing the line if you answer the phone. But if you get up and leave the room, I won't get mad at you. So Log Manager. Who uses Log Manager today? Oh, you don't count, Mike. You know. I know. Exactly. Log Manager is the single coolest tool that you should all go back and put into your production environments tomorrow. You guys have heard this before, I'm sure. I've told you guys about. And it's still not in production because you're doing other stuff. I know you guys. It's really the single coolest thing that I want you to put into production tomorrow. And how do I want you to put it into production? I'll tell you in just a minute. But what Log Manager does is you can give it a list of things that you want to generate a lot of verbal diarrhea about, and it'll write it to a log file. So you can say, you know what, I want 4GL trace, 4GL transaction, and I want query info. And so 4GL trace, for example, will tell you every program, every procedure, every method, what were the parameters passed to it, how long it took to run every one of those lines of code, or those procedures or those programs, and it'll spit it all out. And query info will tell you which index was used, which table used, how many database reads were done, and so on and so forth. And I'll show you. And then transaction. So transaction scoping is probably the other thing I see with programmers that they have a lot of difficulty with. So transaction scoping will show you in the log file when the transaction started and when the transaction ended. And why is all of this cool? And why do I tell you to put this into production? Because you can put this into production and you can create a hotkey sequence of some sort in your application that'll enable this on the back end or on the front end, depending if you're using Character or GUI or .NET or whatever. And so you can start logging this kind of information in production, which means that when a production user has a problem, what's your traditional way of fixing it, right? You go to your test environment, you try to reproduce it, it invariably doesn't work in test, so you ask the DBA to refresh the test environment with the production data, then you try to reproduce it and it still doesn't work because test is never exactly production, whereas you can create some kind of magic hotkey sequence in your application to turn this on. The user simply runs whatever behavior they're not happy about. It generates the log. They hit the hotkey sequence again to turn off Log Manager. You acquire the log, whether they email it to you or you know it's created on disk somewhere or whatever. And now you can walk through everything that the user did in a detailed fashion, every procedure, every program, every query, and all the details, everything that was passed. So you don't have to reproduce this. You can see exactly what happened with every little bit. I'm losing people already. It's terrible. Yeah, so you can do this in production. And the other cool thing about it is, how many of you debug programming by doing message here, variable, message here, other variable, message here, other variable? So you can use Log Manager. Look, I have an email. Look at that. You can use Log Manager to put those messages into that log. So you do Log Manager write. This is me, I'm right here, variable x equals x. And you can leave it there, because if you run with Log Manager enabled, then that stuff will be written to the log. And if you're running with Log Manager disabled, well, nothing will happen. So you can leave all your debug messages in your code if you want. So if it's in production again and you turn it on, well, all those messages will appear, and you won't have, how many people have had production users saying, oh yeah, you fixed my problem, but I have to hit OK 46 times because it says OK 3, OK 4, OK 5, OK 72. So you get rid of that problem too by using Log Manager. So we're going to talk about indexes in detail, but this is really the big take-home that I want you to take. Turn this on in production so that you have access to this in production. All right? this is what you get from query info. Now I truncated out all the stuff around there, like the timestamps. So generally speaking, if I have something like for each order, no lock where a sales rep begins D, well, it tells me, okay, here's my prepare string for each order, no lock. I use the table's called sports2000.order. I use the sales rep index. I did 366,000 database accesses, so combined whether it's index or table. And out of those, 182,900 were table accesses. Now, there's a bug that's never been fixed because the index one always says unavailable, but you can all do math. So roughly half of the requests were table requests, roughly half of the requests were index requests. Now, you as the programmer should have an idea of what's normal, right? I don't know if 366,000 reads, 180,000 table reads, if that's normal for what you're trying to do. But if you look at this data while you're programming, you can say, it's only really supposed to return one order record. Why am I reading 366,000 or whatever the number is? So this will give you a lot of information at programming time before the code actually goes out in production and you run it against production data. So very, very cool stuff in the log manager. All right? And you can use ProTop, the free version. And so a lot of programmers, there's a programming mode. So if you go into ProTop, you hit Control-P, which is programming mode. It's kind of a real-time view. So you can run your program here, then refresh the data in ProTop here, and it'll tell you, okay, well, you used the order.salesRepIndex, and you did 182,915 reads. And then you change your code. You run the code again, you refresh the data in ProTop again, and you get whatever the new number is. So you can have real-time feedback between the character version, the free version of ProTop, and your code. So a lot of programmers just have this on their box, and they do that. They've got ProTop on one screen, they got their program on the other screen, and we also encourage people to make that part of your QA. So you don't let code go out into production until you've validated that it's using the indexes you think it's going to use, and the amount of data that you're processing is in line with what you're trying to do, right? So if you're reading 42 million records, maybe it's not quite ready for production yet. All right? Does anybody know the SQL parameter other than Mike? Sorry, Mike. So SQL is a cool parameter. Don't use it in production, but what SQL does is it not only tells you which index you're using, it tells you how deep, how many fields of the index you're using. So again, we found people don't understand bracketing and how the compiler and how the runtime uses the index. So SQL will tell you how deep you're going into the index at runtime when you actually execute the query. And it does this by giving you a bracket on the bottom and the number of lower brackets and the number of upper brackets. Now, don't use this in production because it writes to the database log file. It doesn't write to some temporary log file on your PC. So if you turn this on in production and everybody has this, then you're going to have multi-gigabyte log files very, very quickly. But try it for fun in your environment. And what you'll get is, oh, I even took the slide out, but you can try it. You'll see it has these greater than brackets and less than brackets. So play around with it in production. I took out the slides because I know I'm going to run out of time. And we started late because of Dr. Taylor.
So it's a database startup, not a client?
No, it's a client. Sorry, it's a client startup parameter, but it writes to the database log file, which is a little bit crazy. But it's cool to see because people think that they're bracketing on 3 or 4 fields in the index, but really they're only bracketing on 1 or 2. And in QAD, bracketing on 1 field is essentially not bracketing at all, right? Because the first field is always the domain anyways. So I suppose if you have multiple domains, you are somewhat bracketing, but a lot of our customers, they only have 1 domain in their QAD database anyways, so bracketing on domain is not bracketing. You look skeptical back there. No? Okay. I'm waiting for a correction from the peanut gallery. All right. We're going to talk about the basic rules first, all right? And again, if you have questions or you disagree with me, feel free. Even you, Mike, feel free. First thing, this only applies to the 4GL, the ABL, right? So SQL uses a cost-based optimizer, doesn't use any of these rules at all. You have to update statistics if you're going to be doing SQL queries against your database, and the SQL query optimizer will use those statistics to do what they call they'll select the lowest cost path to your data. The 4GL compiler is a rules-based optimizer. It looks at your query, it cuts it up into little pieces, and then it selects the index based on the rules that we're going to talk about, all right? The most important thing that I want you guys to take away from this section is that the rules that the compiler uses are elimination rules. They're not selection rules. So the compiler doesn't say, oh, based on this and this and this and this, I'm going to select this rule. What it does is it looks at all the indexes, and it looks at your query, and it says, rule number 1 eliminates this index, eliminates this index, eliminates this index, eliminates this index. Okay, now I've got 2 indexes left. Rule number 2, and then he keeps applying them until there's 1 index left, and then he says, oh, I guess I'm going to use this index. So the first thing I want you to change in your thinking is that the compiler does index elimination and not index selection. Very important, all right? And the other thing is that the rules only apply really to a subset of indexes. So the compiler does a pre-pass, and it pre-selects only the indexes that have a leading component that are in your where clause. So, which is why you always have to say where QAD domain equals blah, 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 and blah, 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 and so on and so forth, all right? So the compiler does a pre-pass first, eliminates any indexes that don't have a leading component in your where clause, and then begins to apply the rules, all right? And I hope you guys know this, but field matches rules must be contiguous. So if you have an index on, you know, QAD domain and item and order, and you apply in your where clause domain and order, it's only going to use domain. If you don't supply the middle component of the index, the parser can't use the third component of the index. So you must use your index components in contiguous fashion. First element, second element. Monsieur?
Could I comment on that?
Of course.
That is true for sure, but what you put in the where clause does not need to be in the order that they're
Yeah, that's a great point, great point. And we get this question every time. Does the order of the elements in the where clause matter? And the answer is no, except in one case where it's true, where it does matter. And so there are cases when there are parentheses where the order of your clauses and the order and the things that you put in your where clause are important. They do affect the index selection, but that's another topic. But generally speaking, the order of the fields in your where clause don't matter, all right? So rules continue to be applied until there's only 1 index left. All right, so here's an example. For each customer where state equals Leinster and city equals Dublin. So you'll notice that that first index, which you would think would be a great index for this query, is actually not used, not even selected, because the leading component, which is sales rep, is not in the clause. So he simply can't use this index because you don't have sales rep. And since I don't have another index that starts with state or city, I end up doing a full table scan, all right? And it would have been the same thing. If I had done where sales rep equals something and city equals something else, it effectively would have only used the sales rep part of the index because it can't use the city part since you didn't provide the state part, all right? And then the other thing that's important to know is the compiler can only use the next component of the index if the previous component used was an equality. So if you say where sales rep equals Paul and state equals New Hampshire and city begins with the letter A, it can use all 3 components of the index. But if you say where sales rep equals Paul and state begins N and city begins D, it'll completely ignore the city part because you did a bracket on the state part. So watch out for that too. And that's where things like ZQL can come in handy. If you're not too sure how deeply you're going into the index, something like ZQL will tell you you're using 3 fields in the index, or 2 fields in the index, or 1 field in the index. All right. So for the first pass, so we did the pre-selection. We eliminated the indexes where the leading component of the index was not in the where clause. And so what's the next thing we do? We look if there's a contains. So if there's a contains, it's going to use a word index, all right, if it has to. Second, it looks for unique indexes with all components involved in equality matches. Unique index with all components. Does anybody tell me quickly why this one is right at the top of the... It's not a trick question. Why is that one so important? Unique index with all equality matches. Nobody wants to throw their thing out there. Because a unique index with all equality matches will return one record, right? By definition, it's a unique index. So if there are any unique indexes, it'll filter all the other indexes out first and only leave that one. It'll eliminate all the other ones, and you're only left with the unique index with all equality matches, all right? And then complete equality matches in greater than one index. Now, 4 and 5 are tricky, and they're weird, and they don't always quite work out the way I think. I don't know all the exact rules because I don't have access to the C code of the compiler. The important thing to know about number 4 is when I say complete equality matches in more than one index, I'm not talking about the fields in the index, I'm talking about the fields in your where clause. So if all of the fields in your where clause are represented in the index, that has a higher precedence. And then afterwards is most active equality matches. And I'll show you some examples afterwards so you can understand. And then now we get down to, okay, well, I don't have very clear equality matches. Let me see, do I have any range matches? Greater than, less than, begins, those are range matches. And then sort matches. And there's a trick for sort matches too. There's a little gotcha with sort matches that we'll talk about in a minute. And then at the very end, if there's still more than one index remaining, well, is one of them the primary index? If the answer is yes, pick the primary index. And then the one that burns people the most is if none of them are the primary index, the compiler will pick the first index alphabetically by name. And the reason why this burns people is because you could have code that works great for years, and then you add a new index that's similar to that one with an alphabetically earlier name, and then all of a sudden this program that's worked fine for 10 years now starts using a different index. So you have to watch out for that particular case. And I've seen this happen in production. So it's a nice little gotcha moment when these things kind of happen. All right. There's a couple of side notes that we want to tell you about. The first is what we call the superset selector. So if you have an index on customer and an index on customer plus state, and your query has both customer and state, the index, the compiler will automatically eliminate the superset. All right, it'll say, look, I have customer and state, so I'm not even going to consider customer because obviously customer plus state should return to me less rows than just customer alone. So we call that the superset selector. And then the other weird thing is the sort selector skip. And what that says is if you have already a field in the where clause, then ignore it if it's also in the sort clause. So if you have a query that says where city equals London or city begins L or something like that by city, it'll actually ignore the by city part of it because the compiler says, well, I'm already using the city to select the index, so I'm not going to use it in the sort selection. And we'll show you an example of that where that could burn you sometimes when you have indexes with the same fields in different orders, and that really screws you up. All right, so just I made a made-up table here I added some indexes to the order table just to make it simple for my examples. Yes, some of these are redundant, all these different sales rep indexes. So I have sales rep a regular index. I have a word index on sales rep. There's a tricky one here. I have sales rep order date, and I have order date sales rep, right, which is valid. You might want to return the data in different orders, all right? So watch out for that. And then you can see I have an index alone on order date here. And the primary unique is on the order number, all right? So what did Peter and I do? We came up with this worksheet approach to enforce the elimination way of thinking as opposed to the selection way of thinking. And so in the workshop, and here we're going to show you how we're going to eliminate indexes as opposed to selecting indexes. So we'll take the simplest example for each order. Well, none of the indexes get pre-selected. All right? So we've had an existential argument about whether this entire screen should be X's or the entire screen should be blank. But the reality is if you just say for each order, the compiler cannot pre-select any indexes or pre-eliminate any indexes because there is no where clause. There are no fields in the where clause. And so all of the fields are now available for selection. But since there's no where clause, all of these elimination rules that we have up until here cannot be applied because they're all elimination rules. All right? I should probably close my email. Anyways. And then, so we get to these two here, which we call selection rules. So he says, OK, I couldn't eliminate any indexes because you didn't provide a where clause. So is there a primary index? Well, yes, of course. And that's why the primary index always gets selected when there's no where clause.
How many tables in Q80 don't have a primary index?
I did not count them. Well, then the primary index will be the default index, right? Right.
That's something on the row.
Yeah. Yeah. Yeah, so, and if I make an aside here, this is where, even if you don't buy ProTop, even if you want to roll your own, I tell you people to trend your table and index statistics. Even if you, once a day or once an hour, you extract the VST data and stick it somewhere just to have it. I tell people to do it. Why? Because you put code into production and you have no idea what the effect is. And so Sunday the code goes into production, and Monday you go into work and you cross your fingers, because no matter how much you tested, until the code goes into production and you see all the interactions of codes and the locking and the interlocking and who affects what and who's running what at the same time as whatever else and what data is changing, you never really know the effect of your code until it goes into production. And so trending data, again, whether ProTop or some other tool, it tells you on Friday, this is what my data looked like, and on Monday, this is what it looks like, and what changed. Okay, so I mean, I've seen this where Monday morning, all of a sudden, the reads in the order table go from a few thousand per second to a few 100,000, and you're like, well, what happened? What did you put into production? Oh, we put this module into production. We start digging in, and of course, there's some code error there, but we would have never noticed it potentially. Or we would have never been able to track it to the code change because we weren't trending the data. So trend the data if you can, all right? So here's where sales rep equals BBB. So the pre-selector goes by first, and what does he do? He eliminates all the indexes where the leading component is not sales rep. So we eliminate all those, so we're left with two. I basically eliminate the word index because there's no contains either. So now I've eliminated all but two of my indexes here. So I say, okay, is there a unique index with any of these? The answer is no. Is there a complete equality match of the fields in the where clause? And the answer is yes, and the sales rep index is picked here. All right? Now it gets trickier though. I'm showing you the easy ones, but they get trickier. All right, where sales rep equals this and order date equals that. So why is it tricky? Order date is only on order date. Sales rep is only on sales rep. SREP date is sales rep plus order date. And date SREP is order date plus sales rep. Just the same fields in opposite order. So we go through elimination. So the pre-compiler, the pre-pass, eliminates 3 indexes because they don't have a leading component in the where clause. Or 4, sorry. All right, none of them are unique, so we don't eliminate anything. Then I say, which ones have complete equality matches? Well, these 2 fields are complete equality matches into those 2 indexes, sales rep, order date, SREP. All right, do I have most active equality matches? Yeah, they're both 2 equality matches. That's great. I have no range matches. I have no sort matches. Neither of these is the primary index, so I pick the first one alphabetically by date. So this data will come back to you by order date by sales rep, simply because the name of the index is before the other name. So whatever you think, this is the order that the data is going to come back. Yeah?
And this might be one of the few situations where it would be legit to use index.
I will get to that.
Okay.
I will get to use index in just a minute. There's a couple of situations like that when you talk. Yes. Okay, I'm there. It's okay. It's a good segue into it, you know. I come into your office. I've been to your office. I look at your code, and I see use index. And the first thing I say, that Tim guy doesn't know anything. Doesn't he know you're not supposed to use? and then I erase it, because only horrible programmers use useIndex. And then I break everything, right? And I don't find out about it because that useIndex was really important, but you really didn't hear about it until you did this processing, which did that processing, which put the things on the truck, and next thing you know, you're shipping turkey to Alabama when you should be shipping turkey to, Ohio. I don't know. This is Michigan turkey producers here, if you don't know the gentleman. So as a programmer, if you're going to use useIndex, I want to see a paragraph that says, I put useIndex here on purpose. If you erase it, you're an evil, terrible, horrible person. This is why I did it, because the compiler's doing this, and I did this on purpose. I'm not an idiot. I've been doing this for 20 years. Does that satisfy your need?
It does.
Thank you. I'm glad. Right? So yes, if you use useIndex, document it really so that the next person coming into your code, because believe it or not, Tim, there is life after Tim the programmer, right? James is here. There is life. The next generation. He'll look at your code and say, what the hell was this? All right, let's try again. Sales rep, same one, right? Previous here. Sales rep, order date. But I added this magical little by sales rep here, right? So the usual question here is, well, why didn't he pick the sales rep? I said by sales rep. Why didn't you pick the sales rep? And the answer is the compiler says, well, you put sales rep in the where clause. I'm already going to sort by sales rep, so I'm just going to completely ignore your by sales rep because it's already in the where clause. And the reason why I hate this exact thing is because it doesn't show in your code. Because what's going to happen here is the data is going to come back to the user in order date sales rep. The user will sort locally and then present the data by sales rep. So you think your code looks fine, but it's not fine. It's coming, all the data is coming out of the database in order date sales rep, and then you're locally sorting, which is fine if there's only 10, is less fine if there's 10 million records that you're locally sorting. And you should see, if you're using Log Manager from the previous line, there's a line that says client sort yes or client sort no. So that's why we keep an eye on this client sort to see, did the client have to sort it? Did it use the correct index? So a really important reason for you guys to be doing this kind of validation at the dev end and not after it goes into production, right? Because this is really, really tricky, sneaky, tricky. He ignored your by clause because the by clause is already in the where clause. Sneaky, eh? Did anybody know this already? Nobody ever knows this. I didn't know this until we started building the labs for this workshop. And we're like, what do you mean it picked this index? It's not supposed to pick this index. All right, another simple one here, where order sales rep is BBB and order status is equal to shipped. Notice 2 check marks. Progress has a MultiIndex rule, which says if the where clause uses all the fields in more than one index, inequalities with ands, it'll just use all the indexes. So it'll actually run the 2 queries separately and then combine the data. So it'll do not a union, an intersection of the data, right? Because you're doing an and. The sort order is not guaranteed. So Progress will not promise you in what order the data will come when it does a multi-index query and then combines the data at the end. All right? So same thing. Here, because it was both fields or both indexes have all their fields and it's an and, it was able to use multiple indexes. And just warning you, this is the easy stuff, right? It's going to actually get hard in about 10 minutes, maybe 5. All right, where sales rep is greater than DKP and order date is greater than this date by sales rep. So here it's interesting because you have 2 range matches, no equality matches. So again, we do our pre-pass. We eliminate any index that doesn't have a field, a leading component in the where clause, and we start going down. There's no contains. OK, great. So order date's got order date sales rep, and then the 2 srep date srep. There's no unique, so we don't eliminate. There's no complete equality matches. They're both range matches. OK, most active, there's no equality matches. Oh, most active range matches. OK, I've got range matches here. Here I've got 1 range match, 2 range match, 3 range match here. I don't know why this one is not here. This one's not supposed to be here. Sorry, this one. This is actually 1 of 1, 1 of 1, 1 of 2, 1 of 2. Yes, here. So, and then you get your sort matches. So now because you don't have equality, then the sort match kicks in. And so that's where you get the two here, sales rep and sales rep date. And then you end up picking the first one alphabetically by name. Now this one is tricky. If you want to, again, if you want to have fun with this, which is what I did, you can go in, if you've got your own little sports database, you can go in and rename all the indexes. It takes 1 second to rename an index in the dictionary. And you'll see if you go and rename afterwards, for example. Wait, sorry, I'm screwing myself up here. It's supposed to pick first alphabetically by name, which is this one. Oh, God. I hate this slide. No, I'm going backwards. I was right. Sorry. So yes, it did pick the first alphabetically by name. I got ahead of myself, or I thought I did, but I actually didn't. All right. Here's another simple one, where order date equals this. So how many people would have guessed that this would pick the order date index? Me too. But it doesn't. It picks date srep. And we think it picks date srep because it's first alphabetically by name. We think. Because we would have thought that we have most equality matches in the where clause and in the index, but because it's most equality matches in the where clause, they both here get 1 of 1 and 1 of 1, and so neither gets eliminated, and so you end up picking the first one alphabetically by name. And there's my tricky one that's coming here. Here's my tricky one. Now let me add the ship date. So order date equals and ship date. So order date 1 of 1, date srep. So that one is order date and sales rep. So I've got 1 of 1. And then that one is ship date order status. So I've got 1 of 2 for date srep. And I've got 1 of 2 for ship date order status. So we go down the list and we say, okay, I still have complete equality matches. Order date is in 1, that's great. And then order date is 1 there, and ship date is 1 there. All right, so they're all equal so far in the compiler. There's no range matches, there's no sort matches. None is the primary index. And so, of course, in all my wisdom, I expected date srep to be selected by the compiler, but it is not. He actually selects order date, and I don't know why. And we tried to find out why, but we had been bugging the guy who wrote this too many times, and he started ignoring our emails, basically. Someone on your old team, Fernando. So he stopped spending time in the C code explaining all of these little nuances to us. Why do I show this to you? Because I think these slides and these rules right now are the closest to reality that exists documented anywhere in the Progress world. I don't think there's any documentation, even by Progress, where the rules are explained in more detail than these slides right here, but we're still wrong under certain situations. So always test, and verify, test, and verify when you're doing these kinds of things. All right, some little gotchas. Expressions break bracketing. So the minute you put something around a field, that field pretty much is no longer going to be used in the where clause. If you say where month of order date is 1, the compiler cannot use the order date in the index because he needs to bring all the order dates back to the client so the client can extract the month and then, do the sorting and the filtering. Begins does not break bracketing because begins is like a greater than or equal to, right? So begins doesn't, but matches does break bracketing. So remember that when you're doing your code, if you put parentheses and a function around a field, you're basically breaking bracketing there, all right? And when in doubt, I've been saying always test and verify. So we're just showing this one. If you do month of order date, it's basically like saying for each order with no fields at all. All the filtering gets done on the client side. All right? Any questions? I'm going to jump into OR clauses. So a little bit similar, we're using the customer table for these examples. All right? Pretty simple. All right. What indexes are used? You can look at them here. I know it's hard. I'm sorry. There's an index here on country. There's one on country postal code. There's one on name. There's one on sales rep. oops, don't blank me. So for name, I've got a one on name, and for sales rep, I've got sales rep and sales rep country credit limit. So which index is used here? Somebody venture a guess. Come on. Name and sales rep. Anyone else? Sorry? He says full table scan. All right. Name and sales rep. So the second multi-index rule that Progress has with an OR clause is if any of the leading components of an index are involved in an equality or a bracket, it can use multiple indexes as long as you're using leading components in the OR clause. All right? So now you see this. It's 2, right? This one. It is a trick question. Come on, somebody say something.
I'll say
Name. Anybody have a different answer than name? Does somebody have a different answer than name? The answer is name 2 times. All right? Why? I'll tell you why. I think it's in the next slide. What? The 4GL compiler, when it sees an OR, it actually splits the query in, we call them logic trees, all right? It splits the queries into multiple queries. So it basically starts building your query, then it hits an OR, it stops, and it builds another query from there. So he says, oh, this is one query, let me just stick it over here, we'll evaluate that one. Then the OR, then he starts building the next query, he hits another OR, he says, oh, here's another query, we'll evaluate that. And then he keekeeps going until he hits an AND, or the end of the query. So when you are using ORs, every subquery on each side of the OR is actually evaluated by the compiler as a separate query on its own. All right? And so that's why for the name equals Kufalis or name equals judge, he actually split those. He ran name equals Kufalis, got this data set. He ran name equals judge. He ran that data set. He unioned the data, return order not guaranteed, and he brought you back the data. All right? So that's the important thing. A logic tree is built until we hit the AND statement. And where it gets really, really ugly, we'll see after, is when you start throwing parentheses in. But just graphically to show you this, really if we're using our truth tables, our elimination tables from before, he really splits them into 2, evaluates the 2, selects the index for the 2, executes the 2, and then combines unions the data. All right? All right, who wants to tell me how many indexes are used here? And I was so nice to like indent all the parentheses for you. Who says 3?
I would have said 3, but I'm sure it's going to be wrong.
Who says 4? We have only one. Who says 5? Everyone's like, maybe just me. I don't know. It might be 5. Who says 6? She says 6, but I don't. Nobody. Okay. 5. For each customer where customer name equals Kufalis. Oh, there's one. Or, but now I'm in the bracket, in the parentheses here, right? Customer name country equals AAA, or, there's number 2, customer name equals Kufalis and customer country equals DEN. Oh, those are in parentheses, multi-index rule with an AND, because I have an index on name and I have an index on country. So there's 3, 4. I break out of my parentheses, or sales rep. All right? Now notice, here there's no 2 sales rep because it's an AND. And even though it makes absolutely no sense to have this, don't look at the logic of my examples. Understand that he picks 1. All right? Look at this carefully because the next one's harder. Okay? Look, everyone's absorbed this. I've got time. I'm doing good. Okay. It's only subtly different from the previous one. Pay attention to the ors, the ands, and the parentheses. Is anybody annoyed by the dingling chandelier, by the way? Who says 3? Who says 4? Nobody's saying nothing. Who says 5? 5, 5, 5. Who says 6? You changed to 6.
I held up.
Oh, 6. Okay, sorry. Who said 5? Who said 6? Who says 7 or more? 4. So I broke it with this bloody and here. So it's the same thing for each customer where, okay, open the parentheses, name equals Kufalis, or, there's 1. Country equals AAA, or, that's 2. Then I create another bracket set here. Name equals Kufalis and. Well, the minute I put the and there, I broke it. Nothing after the and can possibly be its own query. The minute I put an and in, it breaks this breaking up of the queries. And so this automatically becomes 1, this piece here. 3, and then the one on the outside, which is 4. Screw you up, eh? I know, I'm a terrible person. I'm like this with my kids, too. It's horrible. But wait, there's more. All right. Just a couple of other side things, because I'll close up. Actually, yeah, I went fast on time, too. I thought I was going to be short on time, but I zipped through it, but I'm fast on time. Unknown values. So important thing to know, unknown values sort higher, later than known values. And so progress, we had this talk, I don't remember who we talked to. We talked to, I don't know if it was Gus back then, but when Progress first created the language, they had a discussion about whether the unknown value should be allowed in unique indexes. And the decision was that no one would be crazy enough to leave an unknown value in a unique index for any length of time, but we don't want to stop the business processing, so we'll allow it because we assume that the programmer will eventually assign the unique field in the index. But of course, programmers never do what they're supposed to do. And so today you're allowed having these unknown values in unique fields. But important to know that they sort higher. So customer by cust number descending, you can have a whole bunch of question marks here. All right? Now, how do you fix that? By setting the field as mandatory. But in a temp table, you can't create mandatory fields. So if you have this situation in a temp table, you need to deal with it yourself programmatically. All right? Case sensitivity. So we are spoiled in the progress world in that generally we consider progress to be case insensitive because people don't mark fields as being case sensitive, right? And we just generally are not case sensitive in the progress world. The reality is case sensitivity is a function of the field and not a function of the index. So if you mark a field as case sensitive, then the accompanying index will also be case sensitive. But you cannot have a case insensitive field and somehow try to create a case sensitive index. And then you get, who deals with all kinds of weird non-English languages in their environments? Well, you do, yeah, a couple of people. So this is where it gets weird now, because now you start talking about collation tables, and how do you sort? Do you sort capital letters at the beginning, or do you ignore the capital letter and sort them in the middle, you know, along with the lowercase letters? And then word break tables, where do you break words up? And then this whole other commotion arrives about how you sort stuff and how does data appear to you afterwards, all right? So if the field's case sensitive, then the index will be case sensitive. But word indexes are never case sensitive. All right? So even if you have a case sensitive field, if you apply a word index to it, the word index will be case insensitive. All right?
You can have those collation issues also if you have different data sources. One from maybe Microsoft SQL and one from DB2.
Yes. Yes. So if he's saying, the comment is you can have collation issues based on data sources. So if you have data coming from SQL Server or from DB2, I think a lot of times from what I've seen, when you have those kinds of issues, a lot of times it's because the translation is not occurring properly. So you should be translating into the correct database code page. So if you're UTF-8 or ISO 8859, and so I'm from Canada, French Canadian, the bloody accents on all the characters, and back in the version 6 days, you know, we had IBM 850. It was a major pain in the butt. And then when everyone migrated to version 7 and everyone went from IBM 850 or in the French world to ISO 8859, it was a complete disaster of conversion because people did not know, they didn't understand, so they didn't convert properly. So a lot of times what I see in this case is that the data is not being converted properly. And then it gets really ugly if someone tries to fix it halfway through, because then you have data that's been converted differently, and then fixing it is a manual job. It's almost impossible afterwards. All right? Where no index is needed, of course, row ID. If anybody's using rec ID, please stop. If you have rec ID in your code, please remove it. I know that's not as easy necessarily as just substituting the word row ID for rec ID, but you should be doing that. Is anybody using table partitioning or no multi-tenancy, but table partitioning? Table partitioning really will not, the code will not run. It will simply say, you cannot use rec ID against the table partition database. And so that's how you find all the rec ID keywords in your code. You run your code until it crashes, and then you find it and you fix it, right? That's how you guys do all your programming. Right? So yeah, it won't work. So you should be using row ID, and if you have rec ID, you should be actively working on removing the word rec ID from your code. Yes?
We only use rec ID in certain browsers that apply.
So my big problem with rec ID is that it's 32-bit, so which is fine as long as you don't have more than 2 billion rows in the table. So that's the first problem with rec ID. They're fine. Rec ID and row ID are, the number part, if you will, is interchangeable up to 32-bit. But again, if you go into the table partitioning world, in the one of the upper orders of the 64-bit row ID is the partition, because you can have the same table in multiple storage areas, so you can have the same table have multiple records with the same rec ID. They'll have different row IDs because there's the partition portion of the row ID that's going to be different, all right? So you're fine until you're not fine, which is why I say you don't need to go home, scream, and do it all tomorrow, but you should be actively removing those and certainly not adding more rec IDs into your code. Fair enough?
And definitely not storing them.
Oh, God. But that's been true for 20 years, and I still see it, but yeah, yes. There's none of that in QAD, it's all right. But you might have done it in your custom code, but yes. And then if you do table scan, is everybody on a moderately modern version of 10 or 11 of Progress, right? And if you have type 2 storage areas, so if you, in fact, so this is known in the SQL world, maybe less known in the Progress world, but if you're going to kind of read more than a third or so of the table, you might as well do for each table scan. So if you just do for each GL hist, you're going to index read, table read. Actually, index read, table read, index read, table read, index, you know. So you're going to go through the index tree to find the record, process it, go through the index tree, find the record, process it. If you're going to read the whole thing anyways, or, you know, I say even up to about a third, just read the whole bloody table. It's going to be cheaper to read the entire table, all right? Now, if you do that, does anybody use private buffers? I'm going aside here because I've got an extra couple of minutes, but does anybody use private buffers? So in your session, you can set private buffers. So what you can say is, I know in my code that I'm going to read a gajillion records. So you can set this private buffer parameter in your session. What it'll do is it'll limit the number of -b buffer slots that the execution of your program does. So rather than polluting the entire -b of the entire company because one Yahoo wants to do a GLTR history report for all of 2017, 18, and 19, you can tell them, you're only going to read that data one time, so set his private buffers to 64, let him run in his little 64 buffers, doesn't affect the rest of the business, and then at the end you turn it off in the session. So there's another, not related to this, but another cool little performance trick if you know that you're going to be reading a massive amount of data. But generally, again, you can do the performance. Doing for each table scan will be faster probably once you pass about a third of the records. All right? Temp-table anomalies. There's no index on the index name in a temp table. And since there's no index on the index name in the temp table, everywhere in the rules where I said first alphabetically by name, it's actually going to be first by order of definition for a temp table, all right? And fields can't be marked as mandatory, which is what I mentioned a little bit earlier. And that's the end.